If yes, then please solve this question. An alkene is known to be either but1-ene or but2-ene. When heated with concentrated acidified potassium manganate solution, that means we are doing the oxidation of alkenes, bubbles of carbon dioxide gas were given off. Okay, so bubbles of carbon dioxide were given off in which type of alkene? But1-ene or but2-ene? So you have to name the alkene. This is question number 1. Question number 2 is that pent2-ene is heated with concentrated acidified potassium manganate solution. This is also the question of oxidation of alkenes. Draw the displayed formula of the products and name them. Write a balanced chemical equation for this reaction using nascent oxygen to show the oxygen atoms involved. So you have to balance it with this oxygen. So please solve it in your notebook. Done?
Done.
So what should be the alkene in question number 1? But1-ene or but2-ene?
But1-ene.
Yes, very good. It is but1-ene. When but1-ene, it is oxidized with concentrated acidified potassium manganate solution. It produces your carbon dioxide, okay, and propanoic acid. Okay, so formation of carbon dioxide, it indicates that the presence of double bond is at the terminal position, at the last position, which gets completely oxidized. But if you oxidize but2-ene with concentrated acidified potassium manganate solution, then it will produce ethanoic acid because it is the internal double bond. So carbon dioxide gas is given off. So from carbon dioxide, you can assume that alkene must be but1-ene. Question number 2, draw the displayed formula of the products and name them. Pent2-ene is heated with concentrated acidified potassium manganate solution. Pent2-ene means we have 5 carbon atoms. At the second position, we have a double bond. This is CH3, this is CH2, this is CH, CH, and CH3. So when you oxidize it with KMnO4, what is the product?
I said it's ethanoic acid and propanoic acid.
Yes, you just have to cleave this double bond, okay, and we have to add OH here and OH here. So it becomes 1, 2, 3 carbon atoms. That means propanoic acid, CH3, CH2, C, double bond O, OH. So it is your propanoic acid plus CH3, CH2, sorry, CH3, C, double bond O, OH. It is your ethanoic acid. So displayed formula you can easily write by displaying all the bonds. So we have ethanoic acid and propanoic acid. Write a balanced chemical equation for this reaction using O to show oxygen atoms involved. So how you show it? You have to write first pent2-ene, CH3, CH2, CH, double bond, CH, CH3. Clear? Then you have to add oxygen. Then the reaction is, it is ethanoic acid plus propanoic acid. Now you have to just balance the oxygen atoms. There are 4 oxygen atoms, so you have to write 4 oxygen here. Is it clear?
Yes. Yes.
So now this is your homework question. Please note it down. 5 questions are there. All the 5 questions are easy.
I'm done. I'm done.
Now solve this question. pH means it is a phenyl ring or benzene ring. Phenyl is known as benzene ring. What should be the product of this reaction? It proceeds through carbocation intermediate, if you remember. We have studied the alkene when it reacts with HBr. What is the product? Okay, so it proceeds with carbocation intermediate. This is electron rich. So electron rich density, it will attack to the, here we have H plus as an electrophile. It will attack to the electrophile. So carbocation formation will occur. And at that carbocation, your Br minus will attack. So make the product.
I'm done, I think.
So what should be your product?
I got 1 bromo, 2 phenyl propane.
1 bromo, 2 phenyl propane. So let us see how it goes. So here, as you know that this is double bond, this have higher electron density, it will attack to this H plus. Okay, so at which carbon your carbocation will form? First carbon or second carbon? Tell me.
Ma'am, could you repeat yourself?
I'm saying at which carbon your carbocation will form? At the first carbon or second carbon?
First.
Yes. Why at the first carbon? Because this carbocation is stabilized by a phenyl ring. Phenyl means you have a benzene ring. Okay, so it is participating in the double bond. So this is stabilized. Why carbocation is on the first carbon atom? Because this carbocation is stabilized by dispersal of positive charge. Dispersal of positive charge over the phenyl ring. So that's why your carbocation should be on plus carbon number 1. So if carbocation is on the first carbon, then at the second carbon you have hydrogen which gets attached, right? Then what happens? Your bromide ion will come at this carbocation, negative plus, and then our product is pH, CH, Br, CH2, CH3. What is the name you are telling me? Please say it again.
Ma'am, could you please, okay, I understood the cation part, and then after that you cut off. Could you please?
Which part?
I understood the bromine with the negative and then the carbon with the positive, and then you cut off.
Okay, I'm again explaining what we have done. So this is my reactant. Okay, you have to react it with HBr. So in HBr, you have H plus ions and bromide ion, H plus and Br minus ion. So this reaction, this is your electrophilic addition of alkenes. This reaction proceeds through carbocation intermediate. So your carbocation should be formed at carbon number 1 or at carbon number 2. At any carbon, your carbocation formation can occur. So we have to see, we have to apply our knowledge that at which carbon carbocation formation should occur. At first carbon, it is stabilized. If we make the carbocation at first carbon, this is stabilized by dispersal of positive charge over the benzene ring. Benzene is something like this, right? pH is benzene only. So this positive charge, it is going in resonance with this benzene ring. It is stabilized with this resonance. Okay, whenever you have a carbocation on the adjacent carbon of this phenyl ring, then it is always stable. It is known as your benzylic carbocation, which is very, very stable because it participates in resonance with this phenyl ring. So that's why we have made plus charge, that means carbocation on first carbon. And if you make carbocation on first carbon, then the hydrogen will attack to the second carbon, right? Hydrogen will attack to the second carbon. So only this I have done. All the other bonds are same. pH is same, hydrogen is same. Only the formation of carbocation and the attack of hydrogen at the second carbon. Next, your bromide ion will come. Bromide is your nucleophile. So nucleophile will attack the carbocation, electron deficient species. So it will attack here, and the product is this one. Now, if we name this product IUPAC name, so it is 1, 2, and 3. So its name should be 1 bromo, 1 phenyl, 1 bromo, 1 phenyl propane. Is the IUPAC name. Got it?
Yes.
Do you have any doubts, Shama?
No.
So can I erase this slide?
Yes.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So next is a conceptual question that why do the carbon-carbon bonds rather than carbon-hydrogen bonds break during the cracking of alkanes? When we crack the alkanes, then our carbon-carbon bonds will break. Why not the carbon-hydrogen bonds? What do you think should be the answer? What should be the answer? Why do carbon-carbon bonds break? Why do the carbon-carbon bonds rather than carbon-hydrogen bonds break during the cracking of alkanes? Because the bond dissociation energy of carbon-carbon bonds is lower. Write down. Since the bond dissociation energy of carbon-carbon bond, it is, you do not have to remember the value, but it is 348 kilojoules per mole, is lower than bond dissociation energy of carbon-hydrogen bond. Therefore, during cracking of alkanes, carbon-carbon bonds break easily than carbon-hydrogen bonds. Okay, question number 2 is, which of the following has highest boiling point? Methyl pentane, 3-dimethyl butane, 2-dimethyl butane. So, which of the following has highest boiling point? So, I am giving you the hint. As the branching increases, boiling point decreases. Now, what should be the answer?
2-methylpentane.
Yes, answer is 2-methylpentane. So the reason is that as the branching increases, when you increase the branching, then surface area will decrease. If surface area will decrease, then the magnitude of van der Waals forces of attraction, it will decrease, and therefore your boiling point will decrease. Now 2-methylpentane has the largest surface area, that's why it has the highest boiling point. Further, because of the presence of two branches on the same carbon, 2,2-dimethylbutane, it has lower surface area, so it have a lower boiling point. Okay, which have greater boiling point in second and third? Can you compare in second and third? 2,3-dimethylbutane and 2,2-dimethylbutane.
Two 2-dimethylbutane.
2,2 or 2,3? Is it 2,2 or 2,3? Make it butane. 2,2 is something like this, and 2,3 is something like this. So surface area is increasing in which part? A part or B part? So you have to remember here that in this case, in 2,2 and 2,3-dimethyl, 2,2 and 2,3-dimethylbutane, if you have the presence of two branches on the same carbon, two branches on the same carbon means I'm talking about 2,2-dimethylbutane. So it will have a lower surface area. So that's why its boiling point would be lesser than 2,3-dimethylbutane. So 2-methylpentane is highest, then 2,3-dimethylbutane, and then 2,2-dimethylbutane. If it is on the same carbon atom, then your surface area will decrease and boiling point will decrease. Same effect happens in melting point. As the branching increases, the packing of the molecules in the crystal lattice become less close and melting point decreases accordingly. Can I erase this slide?
Yes.
Last question for today's class is an organic compound C8H18 on monochlorination. That means only one chlorine is added, not all the steps. On monochlorination gives a single monochloride. Write the structure of your hydrocarbon. C8H18 should be what? Now it is monochlorination. That means you have to add only chlorine. You have to add chlorine only one time. Okay. So it means your all the hydrogens should be equivalent. If there are CH3, then it should be CH3 only. Because if you add CH2, then there is no one product, because you can add Cl here in CH2 also. So all should be CH3. Your hint is that 18 hydrogen atoms, they should be equivalent. So that you can replace one hydrogen with one chlorine. So either make CH3 or the single carbon atom, so that there is no hydrogen to replace. Okay, so the answer is 2233 tetramethyl butane. Now draw it. Butane 2233 tetramethyl. Count the hydrogen atoms. It is 3, 3, 6, 6, 3, 9, 9. It is 3 into 6, 18. And carbon is 1, 2, 3, 4, 5, 6, 7, 8. So yes, it is matching our formula C8H18. Now if you replace hydrogen with chlorine, then you have only this product. CH2Cl, C, CH3, C, CH3. So this is the organic compound which on monochlorination, it gives a single monochloride. If you remove it here from here, if you remove it from here, all are equivalent. Okay, all are equivalent. This carbon is also connected with a carbon and a CH3. This is also connected with a carbon and CH3. This is also, so all the carbon atoms are equivalent here. So the answer is 2233 tetramethyl butane.